The question is asking us to find the angular momentum of the moon of its rotation to its orbit. So essentially, find the ratio of the angular momentum of the moon's rotation to the angular momentum of the moon's orbit. So for orbit, we're going to say that I equals mRO squared, where RO is distance from Earth. And for rotation, we have that I equals 2mR m squared over 5. This is simply the moment of inertia for a sphere, and rm it is equal radius of moon. So we have to realize that if the moon orbits the Earth always facing the same side, this means that the angular velocity of the orbit equals the angular velocity of the revolution. So that means that when we do this, this is going to equal we'll just say I of rotation omega rotation over I of orbit omega orbit. So this is going to be these two terms are going to cancel out, and we are ending up with I sub r. So this term would be r sub r, and this term would be I sub o. So we can say 2m r m squared over 5, and then times essentially 1 over mRO squared. So m cancels out, and we are left with 2r sub m squared over 5RO squared. And we can find this and say that this is 1.737 times 10 to the 6. So this is the radius of the moon divided by 5 times 3.805 times 10 to the 8th squared. This is the radius, this is the distance from the moon to the Earth, and this is going to equal 8.336 times 10 to the negative 6th. So this will be your answer essentially to this. So essentially, the angular momentum of the moon's orbit is much greater than the angular momentum of the moon's rotation, because again, the angular momentum of the moon's rotation is simply equal to the angular momentum of the moon's orbit times 8.336 times 10 to the negative 6 power. So again, that right here, this right here will be your answer for that part. And that's the end of the solution. Thank you for watching.